Hello friends, today I am going to discussing about another example, maths behind the GNNs with Python programming. So this example is a little bit complexity compared to the previous example one. So how a GNN works? So what are the 5 points here? The same 5 points I was explained in previous lecture. So anyhow I will explain point by point. So point 1 is the starts with the node features. Second, message passing. So here each node sends their own features to its neighbors. Point 3, aggregation. So aggregation means here each node collects the information from the neighbors. Point 4, and updates. Updates means combine the old information with the new information. Step 5, repeat for few rounds. Rounds means layers. So information travels further in the network. So these are the ways the GNN works. Now let's see the example. So here the maths behind the GNN's example-2. Here there are the 5 nodes. There are the 5 nodes. In these 5 nodes, each node has feature vector of length 3. So it means here the node A has the 3 features 0, 1, 1. So this is the feature A. This is the feature A, and this is the feature B vector, feature C vector, feature D vector, feature E vector. So here the every node has the feature vector of length of 3. So in this equation there is a matrix X belongs to R n by C. Here R is the relation. So n means number of nodes. So what are the nodes here? A, B, C, D, E, 5 nodes. C means the number of features per node. So here every node has the 3 features. So node A has 3 features, node B, node C, node D, node E. This is the feature F1, feature F2, feature F3. So in previous example only one feature, one value, but here if I am taking the number of features per node is 3. Next, so in this image now you can see A has the features. A has the feature 0, 1, 1. A has the features 0, 1, 1, and B has the features 0.5, 1, 0.2. C has 0.2, 1, 0.5. Similarly D and E. So the graph structure. So graph structure G is equal to combination of the vertices plus edges. So vertices means the nodes. What are the nodes here? P, A, B, C, D, E, and edges means A is connected to B. This is edge 1. So this is edge 1, and A to C. This is edge E2, and this is E3. So this is E3, and this is E4. So they are the 4 edges. So what GNN does here? So in graph neural network, each node updates its feature vector by combining. So what are the combining here? First of all, every node has their own information, means own features, and second, neighbor node features. So own features plus neighbor node features. So what is the math behind here? There is a formula. That formula is the neighbor mean used to build the message for the first GNN layer. You can see this is the formula here. In this formula, mi of k. So here k means what? So if it is the first layer, layer 1, we are going to set the k value 0, because we aggregate the initial feature vector, initial features to create the message MIFJ. So for creating MIFJ, we need to initialize the feature vector k is equal to 0. So in this notation, what is mean by I? I means the nodes we are updating. So which node we are going to update? A, B, C, D, E, E. Among the E nodes, among the 5 nodes, which node we are going to update? That is the I. N of I means the neighbors of the node I. So which means the nodes directly connected to A. For example, A is connected to B. So A and B are the neighbors. And B is connected to C. B and C are neighbors. But A and C are does not neighbors. Why? Because A and C are no connection. So A and B are neighbors, B and C are neighbors. So mod n of I. So how many neighbors I, which means the degree. Hj of 0. Hj of 0 means this is the initial feature vector for the neighbor j. Mi of 0 means the mean of neighbors feature vectors. So means that there is a message to node I in the layer 1. So I will explain in detail this formula during mathematics. Don't worry. So first, this is the formula for neighbor mean. This is the formula for neighbor mean, or otherwise used to call the aggregate mean, MIFJ. So for each node I means for each node A, B, C, D, E. Next, how we are going to update each node? This is the formula. So this is the standard GNN update rule. So hi of k plus 1. What is mean by k here? Hi of k means the feature vector of node I at layer k. For example, at layer 1, the k value will be 0. At layer 2, k value is equal to 1. At layer 3, k value is equal to 2. So first of all, we are going to calculate the at layer 1 what are the updated values. So at that time we are going to kept the k value is 0. So that is the hi of k. N of I means neighbors of the node I. So here AGG means the aggregation function. So what kind of aggregation function you are going to apply? Either mean or either sum or max. So among the different aggregation functions, as a data scientist you can choose any aggregation function. And W means the learnable weighted matrix, and sigma is nothing but the non-linear activation function like ReLU. So this is the way we are going to use the GNN update rule. Now the graph, it is a undirected graph. So nodes means A to B, A to C, A to D, A to E. For neighbors, N of A means for A. Now you can see in this graph, so in this graph, the initial feature vectors. So initial feature vector, actually the formula here, initial feature vectors is A means 0, 1, 1. So 0, 1, 1. So that is called the HA of 0. HA of 0. So initial feature vectors at layer 1, the k value is equal to 0. So this is initial feature vector HA of 0, 0, 1, 1. HB of 0 means this value, HC of 0, HD of 0, HE of 0. So node A has the features. This is the feature vectors. Next, So now we are going to calculate the, now we are going to at layer 1 from h of 0 to h of 1. We know initial feature vector h of 0. We are going to calculate the h of 1. How we are going to calculate the h of 1? So for example, node A. So node A, what is the feature vector here? 0, 1, 1. And what are the neighbors of A? B, C, D. B, C, D. Why? Because, so this is the B, this is the A, and this is the C, and this is the D, this is the E in this graph. So in this graph, we are going to first calculate the for node A. So here the feature vectors are 0, 1, 1, and the neighbors of A means this is the B and this is the C, D. So according to the formula, so what is the formula for mean? The formula for mean is nothing but the mi of k 1 by mod ni of sigma j belongs to n of I h j of k. So here what is the neighbors of B? A, B, C, D. So that's the mean of HB, HC, HD. We are going to take the HB, HC, HD. So here how many neighbors are there? 3 neighbors. So that is the 1 by 3. So 1 by 3 means 3 neighbors. So what is the k means 0. K means 0 means the formula will be here. You can see here. HB of 0 plus HC of 0 plus HD of 0. So 3 means 1, 2, 3. That's why number of nodes are 3. So HB of 0, HC of 0, HD of 0. So what is mean? What is the HB of value? So HB of 0. So HB of 0 and HC of 0 and HD of 0. So HB of value means HB of 0 means this is the values, and HC of 0 means this is the values, and HD of 0 means this is the values. I will show you the previous slide. So you can see here HA of 0, so HB of 0, HC of 0 and HD of 0. So this is the 3 values we are going to calculate for the node A. Now once we calculate the mean of HB, HCD, the final value will be 0.33, 0.7, 0.3. This is for node A. So now we combined with A's own feature. Own features means earlier features. This is the HA of 0, 0, 1, 1. For example, by concatenating or weighted sum. So then multiply by W, apply the sigma, and we get the new representation of A. So how we will get the new A? You can see here. This is the way. So for node A, so updated MA of 0. So MA of 0 means this one. MA of 0 means mean of node A is equal to 0.33, 0.7 and 0.3. So this value, this is the mean of A, which means MA of 0. This is the way we are calculated mean of A. Now you can see here for layer 1 from HA to H1, the aggregation means message passing means mean value. So this is the formula. mi of k 1 by mod n of I sigma j belongs n of I hj of k. So we are computing the mi of j. Mi of j means for layer 1 neighbor means. So for node A, so what is the list of neighbor vectors? HB, HC, HD. So totally 3 nodes. So MA of 0 means HB of 0 plus HC of 0 plus HD of 0 by 3 means this is the MA of 0. Similarly for node B. For node B, only neighbor A. So that's why 1 by 1. According to this formula, only how many neighbors are there? Only one neighbor. That's why 1 by 1 HA of 0. Only one node A. So HA of 0 means 0, 1, 1. Similarly for node C. For node C, only neighbor node only A. That's why 1 by 1 HA of 0, 0, 1, 1, 1. For node D, the neighbors are A comma E. So A comma E means HA of 0 plus HA of E, which means 0, 1, 1 plus 0, 1, 0, 4 and by 2. Number of nodes are 2 here, A comma D, that's why 2. So this is the updated node D. Similarly, updated node E means this is the B. So for node A, which means MA of 0 means this value, and this is the MB of 0, and this is the MC of 0, and this is the MD of 0, and this is the ME of 0 at layer 1. And now you are going to update. So how you are going to update, you can see here. So update means for updation you are going to use the formula. So this is the formula you are going to use. So in this formula, hi of k plus 1 is equal to alpha hi of k plus 1 minus alpha mi of k. So here alpha means I supposed to choose the 0.5 as a hyperparameter. So the same formula I can written like this here. So alpha means 0.5, 0.5 means 1 by 2 hi of k plus 1 minus 0.5 means 0.5, that's 1 by 2 mi of k. This is the formula, this is the value, this is the both are same. So for layer 1 we are going to set the k value 0. So how you are going to update node A? In this formula. So in this formula you are going to simply substitute at k value 0. So whenever I am going to substitute at k value 0, the result will be like this. So hi of 0 plus 1 is equal to 1 by 2 hi of 0 plus 1 by 2 mi of 0. So 1 by 2 hi of 0 means hi of 0 plus 1 by 2 mi of 0. So hi of 0 means what here? This value hi of 0 updated value at node A. In previous step this is the value we calculated. So hi of 0 means 0, 1, 1. This is the initial values of at node A, and this is the aggregation of the node A values. Now I will show you again. Now you can see here in previous slide, you can see here. So here the initial feature vectors means HA of 0, we are already in previous slides I show you the initial feature vector values, and this is MA of A means previously we calculated 0.33, 0.7, 0.3. So in this formula, so I means node A for layer 1. So of hi of j means we are going to take this value 0, 1, 1 plus 1 by 2 this value means this value. So 0.333, 0.7, 0.3. So you are going to calculate, this is the updated values. So now you are going to update A is at layer 1 0.167, 0.850, 0.650. Next. Now similarly you are calculate the for node B. For node B you are calculated the HB of 1 means 1 by 2 0.5. This is the HB values and this is the updated values of MB of A, MB of 0, and this is the HB of 0, and this is the HC of 0, and this is the MC of 0 value, and this is the HD of 0, and this is the MD of 0. For node E, this is the HE of 0, and this is the ME of 0. So this is the way we are going to calculate it. So that's exactly how each I of 1 is obtained. So which means average of your own features with mean of your neighbors. So this is the mean of the neighbors, then this is the average of the own features. So own features data plus neighbors information both are updating in each node. For layer 2, for layer 2 means use H1. So H1 values are we calculated in previous slide. This H1 values we are going to use to compute the H2. So this is the formula for the same. In this formula, so here we are going to take calculated the MA of 1. Why you are going to update the formula MA of 1? This is the formula, which means that for A there are the 3 neighbors B, C, D by 3. So this is the HB1 values. So what are the HB of 1 values you can see here in previous slide? This one. This is the HA1. So this is the HA1 we are going to use to compute the H of 2. This is node A. So this is the HA of 1. This is HB of 1. So this is the HB of 1, and this is the HC of 1, and this is the HD of 1, and this is the HE of 1. So these values I am going to use to calculate at H2. So I am going to use this H1 in previous slide to calculate the H2. So before going to calculate the H2, first you need to calculate the average mean at K value. So here for layer 2 the K value is 1. So in this form you can substitute Mi of 1 is equal to 1 by. So for node A, how many neighbors are there? 3 neighbors. So what are the neighbors? HB of 1 plus HC of 1 plus HD of 1. So this is the HB of 1, HC of 1, HD of 1, and this is the MA of 1, and this is the MB of 1, this is the MC of 1, this is the MD of 1, ME. Why? Because this is only one neighbor, here also only one neighbor, and here for node D there are the 2 neighbors A and E. For E only one neighbor, that is the D. So this is the MA of 1, this is the MB of 1, this is the MC of 1, MD of 1, ME of 1 at layer 2. Next, now I can use the layer 1 vector h of 1 and layer 1 neighbor mean m of 1 you wrote to compute the layer 2. So this is the MEF1 I computed in previous slide. So updated node feature vectors layer 1. So what are the updated nodes node features at layer 1? So this is the HEA1 values HB, HC, HD, HE and MA, MB, MC, MD, ME. So now I am going to update. So update each node HIF2 features at layer 2. So I am going to use the same formula at layer 2 means k value 1. So update rule, what is the update rule? Same HIF2 means alpha HIF1 minus 1 minus alpha MIF1. So alpha means 0.5, which means I can write like 1 by 2 HIF1 plus 1 by 2 MIF1. This is the HIF2. So for node A, I am going to calculate. For node A, I am going to calculate it? HAF2. HAF2 means here in this formula, this one 1 by 2, this 1 by 2 here, HIF1. So HIF1 is this is the values from the previous slide, and the next one is the MIF1. This is the MIF1. So MIF1 and this is the HIF1. You can see in previous slide. So I will take these values. This is MIF1, HIF1. So I am going to calculate here. You can see here. So this is the previous slide. I calculated these values. HAF1, this value 0.167, 0.85, 0.65. These values. This is the values, and these values I am taking here, and calculated the updated value here for at layer 2. Next for node B, node C, node D and node E, and finally the result is like this. For HAF2, this is the values. For HBF2, 0. This value, and HCF2 means this value, and HDF2, so this value, and HEF2 means this value. So this is the each one is the simply average of its own H1 and its neighbor mean means MI1. Next, so now information has been traversed two hopes. Two hopes means A and B. So here the node E has indirectly felt nodes A, B, C through D. So here means that the graph will be, you can see here, this is the B, this is the A, and this is the C, this is the D, and this is the E. So which means node E, this node E has indirectly felt nodes A, B and C through D. Next, for layer 3, similarly I am also for layer 3 means you are going to use the H2 to compute the H of 3, the same formula, and you are going to use the aggregation message like by using this formula you have calculated the MEF2, MBF2, MCF2, MDF2, MEF2. This is the MEF2 value, MBF2, MCF2, MDF2, MEF2, and update rule means HIF k plus 1, the previous same formula. For layer 3 the k value is 2 whenever 2 plus 1, that's why it is hi of 3. Hi of 3 alpha hi of 2, 1 minus alpha mi of 2. So whenever alpha is 0.5 means hi of 3 means alpha means 1 by 2, hi of 2 plus 1 minus alpha means 1 by 2, mi of 2. So now we have calculated the hi of I means for node A HA, HA of 3, HB of 3, HC, HD and HE. So what is the meaning of layer 1? Each node moves towards the mean of first hop neighbor, which means direct connections. Layer 2 means information travels two hops, like E now reflects A via D, which means so here B, A, C, D, E. So at layer 2, E and A. So E and A, so both are connected through D. So that is the layer 2. Layer 1 means direct graph like BD, AC, AD, like that. So similarly layer 3 means features become the more community, so through the entire network. So this is the way we are going to update the nodes information based upon the according to your layers, how many layers you want to use, layer 1 or layer 2 or layer 3. Now I will explain the programmatically. So here you can see here the same graph. First is I have taken the import the numpy. Step 2, define the graph nodes for their structure. So here I am going to define the graph nodes, means edges. So each row from the matrix in the image become the feature vector. So in the feature vectors you can see the directed means graph connections AD, AC, AD, AB, DE. Now I am going to define the GNN rule. So this is the GNN rule. So apply the layer 1 to layer 3. So you can see here the layer 1 information. At layer 0 means this is the initial feature. So what is the initial features here? This is the initial features. So this is the initial feature like this. And I am going to use the GNN layer. So H0 means previous initial nodes, so H0. And the neighbors means what? What is the neighbors here? You are going to calculate the neighbors here. And alpha means 0.5. So now you can compare each layer, you can see here. So in this example, at layer 1, so A is here 0.16, 0.85, 0.65. The same values also you can notice in the program mathematical example 0.16. You can see here 0.16. So 0.16, 0.85 and 0.650. The same values, what is the values I got it here? The same values also I got it in the program here, these values. These values. So this is the updated values A, B, C, D, E. After layer 2, this is the values. After layer 3, this is the values. So here layer 1 means what here? Layer 0 means just original feature vectors. What is the feature vectors we are given? That is the layer 0 means the original features from the matrix. Layer 1 means each node mixes its own features with its neighbors, which means direct neighbors like B, A, C, D, E. So here layer 2 means nodes now carry the information not just from direct, but also the neighbors of neighbors, like so A and E are communicated through D. So this is nothing but the layer 2. Layer 1 means direct graph like B and A and C, A and D, like that. So layer 3 means information is spread across the whole graph. So this is the way we are going to update the each feature vector information. I hope you understand the mathematical example. Thank you.